So we're going to start the section 6.6. Guys, I hope to get through this section, and I hope to get through section 6.7, and then we're done for the year. That's what I'm going to try and get to, all right? So 6.6, it starts out very easy and very nice in the sense that there's not too much math involved. It's a lot of just learning ways to rewrite something, and then the math that is involved right now today is pretty simple. Actually, you can use your calculator, but the chart that I gave you comes in really handy with these two. So let me bring my chart up real quick so I can show you how to use the chart when we get to it. To me, you'll be so fast if you use the chart. All right, here we go. So section 6.6 is all about rational, and rational is just a fancy word for fraction. So this is all about rational or fractional exponents. So if you remember when we were doing those roots of a variable last week, you know, they turned into a fractional exponent. And then sometimes I would say, oh, it doesn't divide. We don't want to create a fraction yet. Well, now we're going to create fractional exponents. Now we're going to work with fractional exponents, okay? All right, so here we go. So guys, just remember, if I asked you to simplify 8 squared, remember the exponent, 2, tells you how many times to multiply the base, 8, by itself. So 8 squared literally means 8 times itself 2 times, 8 times 8, and then we end up with 64. Nice and easy, right? Okay. Well, the problem with a fractional or a rational exponent is, guys, if I asked you to simplify 8 to the 2/3 power, what does that mean? What does that equal? How do I take 8 and times it by itself a fractional number of times? That seems kind of impossible to do. How do I times 8 by itself just a fraction of a time? That's not okay. So we don't really want a fractional exponent. We need a way to kind of rewrite it, basically. So guys, the way we're going to rewrite a fractional exponent goes back to what we were doing last week when you were taking the root of a variable. So guys, think about it. If I asked you, what's the 3rd root of x to the 12th, right? Well, then technically you're taking the 3rd root. So every x to the 3rd that you create, you can take the 3rd root of. So we had to figure out, well, how many x's to the 3rd can you make from an x to the 12th? And the easiest way to figure that out without having to write all the x to the 3rds out was we would take x, and it would be a power divided by a root. That's how we could find out how many groups of 3 you could make from 12. So this became x to the 12 divided by 3. So guys, in reality, a fractional exponent is literally made up of a power over a root. So you're going to be able to take a fractional exponent and turn it back into a root and a power. All right, and then obviously we're able to simplify this to x to the 4th, okay? But if you have a fractional exponent, guys, it's because you have a power being divided by a root. All right, x to the 20th, right? The square root of x to the 20th, we had to figure out how many x squareds we could make from x to the 20th. So we made this x to the power 20 divided by a root of 2. So again, a fractional exponent is literally made up of a power and a root. And we're going to be able to take this and turn it back into the power and the root. All right, and then we were able to simplify this to x to the 10th. So the rule is, when you're dealing with fractional exponents, first, if you start with a root, the nth root of x to the m, we already know is equal to x to the power m divided by a root of n. We already know that rule. We used it all last week. But now, when you have a fractional exponent like x to the m over n, you're going to be able to work backwards in the rule and turn it back into that root n power. So x to the m over n is going to turn into the nth root of x to the nth power. You're able to turn it back into that power and root. So a fractional exponent is just made up of a power over a root. And we're going to have to convert backwards this time. So guys, now when I ask you what's 8 to the 2/3 power, well, whatever the exponent is on, goes under the radical. We're going to turn it back into the root and power. So 8 goes under your radical, and it'll be the third root of it to the second power. So that's really the third root of 8 squared. Now, when you go to simplify this, you can do the root or the power first. I could take 8 and square it and get 64, and then take the third root of 64. You could do that. Or you're allowed to take the root of 8 first and then square it last. Either one of them is equivalent. It doesn't matter whether you do the power or the root first. My rule of thumb is I would rather make something smaller before I make it bigger. So I usually do the root first, make the number smaller, and then I do the power last. So guys, the third root of 8 squared, the third root of 8, if you look at your chart, ooh, I didn't mean that. Go to your third root column, find 8, it's right there, take it all the way home, it's 2. So the third root of 8 is 2, and then you have to square it. 2 squared is 4. So guys, 8 to the 2/3 power is actually equal to 4. Okay? And that's what we're going to do. We have to take these fractional exponents, and we have to put them back as their power and root. All right, so guys, I'm going to actually bring up my chart as I go through the examples down below, so I can use my chart, and I'll do the examples off to the side. But you guys can stay on your notes. All right, so guys, let's look at the first example. They want you to simplify 16 to the 3/2. Okay, well again, we can't really times 16 by itself 3/2 of a time, so we're going to turn this back into the power and root. So whoever the exponent is on, 16, throw it under a radical. And then the 3/2 is going to become a power over a root. So the bottom number is your root, the top number is your power. Now guys, you can put it on the 16 or you can put it on the top of the radical, because I'm going to do the root first. So I like to leave the exponent outside. So now guys, what's the square root of 16? 4. Then you take 4 to the third power. 4 to a power of 3. It meets right there. It's 64. And you're done. So your chart will make this really, really quick. All right, look at the next example. 25 to the 1/2 power. Again, how do I times 25 by itself half of a time? So we're going to take this and turn it back into its radical. So whoever the exponent is on, 25, throw it under a radical, and then your fraction becomes a power and a root. Remember, powers are up high and roots are underneath. So it's a root of 2 and a power of 1. Well, guys, what's the square root of 25? Everybody knows that. It's 5. And then it's 5 to the first power. What's 5 to the first power? 5. The answer is 5. So, guys, this is important for you guys to realize. When you raise something to the 1/2 power, you don't really have to write a root of 2, and you don't have to write a power of 1. So actually, when you raise something to the 1/2 power, it's the exact same thing as square rooting it. So raising something to the 1/2 power is just another way of writing a square root problem. All right, let's go to the next example. The next example is -8 to the 4/3 power. Now guys, notice the -8 is in parentheses. That means that this exponent is on the 8 and the negative side. So that means the negative and the 8 have to go under the radical. So take who the exponent is on and throw it under the radical. Guys, sometimes I don't even take the parentheses away. I'll leave it in parentheses. And then it's going to become the third root to the 4th power. All right, I like to do the root first because it makes it smaller. What's the third root of -8? Remember, you can take the odd root of a negative number and be perfectly fine. So go to the third root, find 8, bring it all the way home, it's 2. But it's not really positive 2, it's -2. So this is -2, I like to leave it in the parentheses, to the 4th power. That means that exponent is on the 2 and the negative sign. So guys, think about it. This is -2 times itself 4 times. -2 times -2 times -2 times -2. It's definitely going to be positive. And then what is 2 to the 4th? 2 to a power of 4 is 16. And it's definitely positive 16. And you're done with that. All right, let's look at D. We got the 81 to the 3/4 power. All right, well, let's convert it back to its power and root. So we're going to throw 81 under a radical because that's who the fractional exponent is on. And then we're going to break this up into the power and the root. The 4th root to the 3rd power. Well, what's the 4th root of 81? 4th root, 81, bring it all the way home, it's 3. So then that's going to be 3 to the 3rd power. What's 3 to the 3rd power? 3 to the 3rd power is 27. And you're done. So again, your chart is so much quicker than using a calculator. And you don't have to worry about typing something in wrong. All right, let's go to E. E is 32 to the negative, 2/5? Okay. Guys, this is kind of a double whammy. We don't want a fractional exponent that has to be converted, but we also don't want a negative exponent. But we've already learned how to make a negative exponent positive. We know to make a negative exponent positive, we have to flip the problem. We have to move it from the numerator to the denominator. So guys, right now, 32 to the negative 2/5, it's over 1. It's not a fraction. So if you have 32 to a negative exponent on the top, you have to move that to the bottom and make it 32 to the positive 2/5. And now your numerator is empty, so now you have a 1 on top. So it actually becomes 1 over 32 to the 2/5. And now we'll just work with this problem in the denominator of the fraction. So it's going to become 1 over, take 32, throw it under a radical. It's going to become the 5th root of it to the 2nd power. So that's going to be 1 over, let's do the 5th root of 32. 5th root, 32, bring it all the way home, it's 2. And then you have to do 2 squared. 2 squared is easy, that's 4. So your answer is 1/4. So don't forget the exponent rules that we've already learned. All right, the last one. You have 1 to the 6/7 power. Guys, 1 is the best number to root, and 1 is the best number to power, because your answer is always 1. This is going to become, throw 1 under a radical. It'll be the 7th root to the 6th power. Guys, what's the 7th root of 1? What times itself 7 times equals 1? 1. So then you get 1 to the 6th power. What's 1 to the 6th power? 1 times 1 times 1 times 1 times 1. Maybe times 1 more, I'm not sure. It's 1. The answer is 1. All right, how do you guys feel? Is everybody okay? Thumbs up at home? All right, so good, nice and easy. If you have a fractional exponent, it can just be converted back to a radical with a root and a power. All right, now the rest, I don't believe is going to involve math. It's just going to involve us rewriting them back in their other forms. All right, so here we go. The directions say rewrite in radical form. So we have to convert these fractional exponents to their radical form. All right, this is x to the 3/4. So if we wrote that as a radical, the exponent is on x, right? So throw x under a radical, and it would be the 4th root to the 3rd power, right? However, because this is a variable, and I can't really take the 4th root of it and know what number that is, then they'll tuck the exponent inside. So they'll probably write this as the 4th root of x to the 3rd. Okay? Again, I like to root first and then power, so I tend to write it like this, but because we can't fourth root, then they're going to give it the power. All right, same thing here. X to the 5 halves, right? Throw X under a radical because that's who the exponent is on. It's going to become the square root. But guys, do I have to write a 2 in this corner? No, it's always understood to be a square root. So you can put it there. I'll never mark you wrong. And then the power of 5. But like I said, in reality, you would see this in a book as X. This would be left blank because it's assumed to be a square root when nothing's written there. And they would tuck the power underneath. So it's the square root of X to the 5th. You do not have to write a 2 there. It's assumed to be a 2 when nothing is there. That is the square root symbol. All right, y to the 1/7 power, right? Throw y under a radical because that's who the exponent is on. It becomes the 7th root to a power of 1. But guys, do we have to write powers of 1? No. So they would literally just write this as the 7th root of y. They wouldn't put a power of 1 because it's assumed to be there. Bless you. All right, with this one, same thing. You don't want a negative root and you don't want a negative exponent. So before we convert this back to radical form, let's fix it. Right now it's assumed to be on top. So we're going to do this as 1 over z to the 4/5 power, and then we'll convert it back now. So it'll be 1 over, throw z under a radical. It'll be the 5th root to the 4th power. But really, because I can't take the 5th root, it'll be written as the 5th root of z to the 4th. They'll put that exponent underneath. All right, guys, the last one. X to the 1/2. Remember what I just told you? When you raise something to the 1/2, it is the exact same thing as square rooting it. Because watch what's going to happen. You're going to throw x under a radical because that's what the exponent was on. All right? It's going to become the square root to the 1st power. But I don't have to write a root of 2, and I don't have to write a power of 1. So it literally just becomes that. And it's assumed to be the square root of x to the 1st power. So when you raise something to the 1/2, guys, it's the exact same thing as square rooting it. Okay. All right, now they want you to rewrite it in rational or fractional form. So now it's going to be given to you in a radical form. You got to convert it back to its power over a root, its fractional exponent. All right, let's look at the first one. So guys, if you had the 3rd root of x squared, put that back as a fractional exponent. Well, guys, take your base, which is x. It's going to have a power of 2 and a root of 3. So that's 2 over 3. It's x to the 2/3. Now again, sometimes if they don't tuck the exponent underneath, this means the exact same thing, guys, right? You would take x out from underneath the radical. It has a power of 2 and a root of 3. So sometimes it might be written like this, where the exponent is underneath the radical, and sometimes it might be written like this, but it's the same thing. Either one becomes x to the 2/3. All right, guys, what about this one? The 8th root of 90. What power is assumed to be on this problem right now if nothing is written there? 1. It's a power of 1. So take 90 out, and it'll be raised to a power of power over root 1 over 8. Now, I could also write this if I wanted to. 90 to the 1/8 power. You can put 90, what you break out, in parentheses to show that 1/8 is on all of it. It's not needed here, but some problems, the parentheses are going to be needed. All right, guys, look at this one. The 7th root of y to the 5th. Take y out. That's what this exponent and root are on, and it'll be a power of 5 over a root of 7. Okay. See how this one definitely has parentheses? The reason it has parentheses is because the number under the radical is negative. The negative and the 20 were both under the radical. So when you go to rewrite this one, when you take negative 20 out from underneath the radical and you're about to give him a fractional exponent, guys, he's got to have parentheses around him. You've got to show that this root and power are going to go back on the negative and the 20. If you write it like this, then whatever exponent you put is really only on the 20, and that means the negative sign would not have been underneath the radical. So in a problem like this, you have to have parentheses so that you can show that the exponent is on both the negative sign and the 20. So then it would be a power of 4 over a root of 7. So again, if you wrote this, you're wrong. Because technically the negative sign is not what the exponent is on, and it would have been this, the negative, and only the 20 would have went under the radical, not the negative sign. So you got to make sure you use parentheses in this case to show that this exponent was on the 20 and the negative sign. All right, the third root of 11 to the 4th, take 11 out, and it'll be to a power of 4 over a root of 3. There's no negative sign, so I don't have to worry about parentheses there. All right, be careful here. Guys, what root is assumed to be here right now? That's the what symbol. That's the square root symbol. So it's got a root of 2. A lot of students, uncommonly, they put a 1 there. You can assume a power of 1, but there is no root of 1. It's always a square root. So this will be 5 to the 3 over 2. Root, a power over root. All right, same thing here, guys. This negative 27 is under the radical. So you want to make sure that this exponent goes back on the 27 and the negative sign. So when you take negative 27 out, make sure you put them in parentheses to show that the exponent is going back on both of these things. And then it'll be power over root 5 over 3. Okay? Guys, if we have to rewrite this back as a fractional rational exponent, what root is assumed to be here? Square root. And what power is assumed to be here? 1. So when you put this back, it'll be 9 to the power over root 1/2. Remember, square rooting something is the same thing as raising it to the 1/2 power. And then the last one. We're kind of a little busy in this one. Guys, just take whatever's under the radical out. What's under the radical? 7x y to the 3rd. All of that was under the radical. Now, put it in parentheses to show that whatever exponent you're about to put on it goes on all of it. Well, guys, what power is assumed to be up here? Because this 3 is only on y. It wasn't on the whole problem. There's a power of 1 and a root of 5. So it'll go back to the root, a power over root 1/5. Okay? Does it seem okay? Pretty, like again, it's not too much math involved, which is always kind of nice. So things tend to move pretty quickly. At home, are you guys okay? All right, how are you guys? Everybody here okay? Yeah? Okay. All right, so guys, here's the drill. Your homework is on this. Whether you just have to rewrite it as a fractional exponent, whether you have to rewrite it as a radical, or whether you actually have to simplify it like we did in the beginning and get a number answer. It's on Delta Math, but I'm not assigning it until tomorrow morning. You guys will have tomorrow. I actually think I made it due like a normal homework. If I assign it tomorrow, I think I made it due Wednesday like normal. But you have tomorrow's class period to work on it and get it done. All right, so there will be no Google Meet tomorrow. Work on this homework on Delta Math that I will be posting in the morning, and then I'll see you guys back here on Wednesday, okay? All right, let me double check your attendance, and then you guys will be good to go. Guys,